Is I'm doing this one for the young people, college students, or under high school. Maybe missionaries, take care of yourself. You understand or not? I just because this is about bio chemical evolution. Is the title. But actually, you don't need that much knowledge, just only high school, ninth grade knowledge on science, and that's better. And also, I know this is here, there's not a lot of doctors and pharmacists, nurses, who study biology a lot actually, but I'm not expert in biology. I just took 101, 102 in college. So, whenever you have a chance, don't ask me any difficult question. I don't know about biology actually. Chemistry, I know just basic chemistry. So if pharmacy is here, don't ask me a question. But truth is simple actually. Simple, so everybody can understand what's going to happen. So I'm going to present what I understood and prepared here. And okay, anytime you have a question, you can ask me. It's okay. Question, what is the basic unit for the living things? Basic unit for the living things. Okay, you know already answered. Okay, if you want to answer, please raise your hand, please. Okay, things here, more description, the parentheses. Something is the basic structure and functional unit of all known living organisms. It is the smallest unit of life that is classified as a living thing, and is often called the building block of life. Okay. Oh. Yes?
Cell phone.
Oh, yeah, yes, it's cell. Thank you. I told you, this is ninth grade level. Answer is cell. Cell is from cell, we can say this is a living things. Living things. Okay? Before cell is not living thing. That's what we call chemical evolution. Okay, usually bioevolution is from cell to above. That's bio. Okay. So in order to be a living thing, has to be first has to be cell. So as a cell, an organelles of cell, and this is a picture of cells. Okay. Here you can see many different components in the cell, and this part is nucleus. This is nucleus, inside many different things, and outside there's so many different components here. So this is all of them is work together, become one cell. This is like actually chemical factory. So many things going on inside, and everything has to be work together. That's how living things can live. So there's so many things inside. So each component, name of each component is what? Organelles. Yeah, organelles. So cell is composed of organelles. Okay? It's not difficult, right? And what are the organelles made out of? That's another maybe a little different question. Anybody? What are the organelles made out of? Yes, so David.
Macromolecules.
Say it again, please.
Macromolecules.
Okay, macromolecules. That's the correct answer. One more easy way, easy word. Protein. Okay. Protein gathered together, they make organelles. And organelles gathered together, come on, one cell is a living thing. Okay, next question. What are proteins made out of? John? Jonathan? No? No? Okay, then Shane, Joseph. Amino acid? Yes, amino acid. Joseph, I cannot believe that you failed some courses. think about, okay, in order to make organelle, we need a protein. So in order to make a protein, we need amino acid. Amino acid was made and then put together become protein. Now, what are the amino acids made out of? That's a more difficult question. But think simply. Just you need to tell you. Yeah, these things, elements. Okay? The hydrogen, helium, carbon, nitrogen. Yeah, these things is element. So element together make amino acid. Amino acid make together protein. Protein make together organelles. Organelle come out one living cell. So is amino acid living thing? No, not yet. Protein is living thing? No, it's not yet. That's what we call chemical evolution. So today I'm going to cover just only. Okay. So again, let's make. The process become a living thing is element gather together become a amino acid. Amino acid gather together become a protein. Protein gather together organelles, and after organelle is going to be cell. But today I'm going to cover here from element to over to here. Okay? If we cannot make, but naturally we cannot make any one protein, then life after that is forget about it. You cannot make any life cells. So I'm going to tell you how difficult it is to make one protein in nature. Okay, this is on a steps to become a conscious observers, which is now after cell. I'm going to show the process organs. Organ means the lung and liver and brain and arms, body parts is what we call organ. When organ get together, become an animal. It's a conscious observers. So mostly when in the textbook evolution, when talk about evolution, they talk about animal to animal, right? Those things on top of here. They never talk about below the animals. How does cell become organs, organ get together become animal? Or how does element become a protein and protein become one cell? They don't talk about those things. So only on top. But still that's a problem, a lot of problems. But they don't talk about it behind. Why? They cannot answer. They cannot prove. Okay, can amino acid be made naturally? So the evolutionists always say that the natural process. Naturally, in times, a lot of time passed through, they happen to be in this way. That's what they say all the time. So now, can amino acid be made naturally? The first step of the chemical evolution is amino acid has to be made first. The answer is yes, amino acid can be produced by natural process. So this is Stanley Miller's spark chamber experiment, which is I'm not sure about the high school student, those grade high school recently. Did you learn these things? Stanley Miller's spark chamber experiment? Anybody remember? No? Okay, I learned actually. When I was in high school, you learned? Yeah, all the time. But they don't teach these days anymore. I talked today the biology teacher. I asked her a question. You teach these things? She doesn't teach it. Why? Because it happened in 1953. At the time, it was sensational. Wow, we made amino acid. That means, yeah, life formed naturally. That's why it has great hope. It was sensation. It happened in 1953. Now, how many years passed? 6 years passed, right? Nothing proved it disappeared. It disappeared, actually. Okay, this is his experiment. He just boils something and water goes in, and then electrical spark chamber. He put this kind of the materials, the water and the methane, ammonia and H2 and carbon monoxide. These things happen, and then he put energy through the electrical spark or discharge. He give the energy, and then they made an amino acid here. They gather some amino acid. That's his experiment. Yes?
If it was an experiment, could they repeat again?
They could repeat again, they could make some amino acid.
Again?
Yeah, they can make amino acid. That's why they think, oh, we got amino acid. That's why they hope that it's possible to make one cell and go up. Okay. Experiment was conducted by Chicago University in 1953. It's Stan Miller. He's a professor in Chicago University in Chicago. He used these kind of gases. At the end of the 2 weeks experiment, he yielded 11 amino acid out of 20. We're saying 20 means in our body, human body, we have 20, and all our protons in our body is made out of 20 amino acid. 20 amino acid. Among 20, around half of them is essential. It cannot be produced in our body, so we have to eat it from fruit, and then 10 of them we can produce in our body. So 20 amino acids we need, for our body. Then can like naturally form naturally. At the time they say yes, but no, it's not. Okay, I'm gonna just describe about his experiment, his problem. Okay, wrong starting material, he used it, wrong condition, and get the wrong result. First one, okay, wrong starting materials. Miller's left out oxygen in gas chamber, actually. Because he put the oxygen chemically very active, they destroy amino acid immediately when they form. So in order to collect amino acid, he intentionally removed the oxygen. So this is a very conditioned experiment. The next one, the same electric spark and puts amino acids together and also tear them apart. Okay. They make it and tear them apart. And he drew the gases out of the spark chamber and put a trap that will save amino acid from destruction. That's what he could get in the laboratory. But in the nature, it's going to automatically destroy it again. And there's one more important thing is here. Amino acids are two different types, left-handed and right-handed. They have same composition, but their orientation is different. L amino acid and right-handed amino acid we call D-type, L-type and D-type. But this is an important fact. The protein now in the living cell are made of only left-handed amino acid. Only left-handed. One right-handed amino acid put together into the left-handed, they cannot make a protein that our body can use. But in the experiment, the both L and D produced at the same time. And this is the 20 amino acid. We don't know. So just remember 20, we need 20 amino acids in our body. So Miller's experiment produced equal number of both right-handed and left-handed forms. That's the fact. Just one right-handed amino acid inserted into a chain of left-handed amino acid would prevent coiling and folding. Later, I'll show the video. You just remember, when amino acids gather together in order to make protein, they have to coil, folding, and they make a specific shape. Then they function as the protein. So they have to coil. So just one right-handed amino acid goes in, they cannot foil properly, cannot make a shape that we need. So one right-handed amino acid that's in the soup will act like a poison. So, and protein will not be operate. Even though it's made it, will not be operate. We cannot use it. So I'm going to show one short video clip. This video clip explains about how could the cell produce proteins, the process.
With computer animation, we can enter the cell to view this remarkable system at work.
They goes into where? What kind of structure is it? This is nucleus in the cell. So all the information is inside the nucleus, DNA. So they go into the nucleus, get the DNA information to make the protein. So they go into this is inside the nucleus. The DNA changes.
After entering the heart of the cell, we see the tightly wound strands of DNA, storehouses for the instructions necessary to build every protein in an organism. In a process known as transcription, a molecular machine first unwinds a section of the DNA helix to expose the genetic instructions needed to assemble a specific protein molecule. Another machine then copies these instructions to form a molecule known as messenger RNA. When transcription is complete, the slender RNA strand carries the genetic information through the nuclear pore complex, the gatekeeper for traffic in and out of the cell nucleus. The messenger RNA strand is directed to a two-part molecular factory called a ribosome. After attaching itself securely, the process of translation begins. Inside the ribosome, a molecular assembly line builds a specifically sequenced.
Right, now here. Okay, this is RNA, right? It carries information. Do you know what is this thing? Yeah, this is amino acid. One amino acid, another one. They connect by the information in order, in a specific order. Okay, they get an amino acid and they will make a protein later on.
Chain of amino acids. These amino acids are transported from other parts of the cell and then linked into chains often hundreds of units long. Their sequential arrangement determines the type of protein manufactured. When the chain is finished, it is moved from the ribosome to a barrel-shaped machine that helps fold it into the precise shape critical to its function.
That's what we call coiling. Okay? Amino acid to make a chain, they coil and make a specific shape. And that's the process right there.
After the chain is folded into a protein, it is then released and shepherded by another molecular machine to the exact location where it is needed.
But that's a protein they made up. So here we can see that clearly. It has to be ordered. Order has to be precise. So inside the chain, even one D amino acid goes in and ruin everything. And also order has to be precise to the end. Then how many amino acids get together? At least 200. The simplest protein needs 200 chains. So fact finding for a protein here. A small protein needs about 200 amino acids arranged in a specific order. While average protein consists of around 500 chains, 500 amino acids. So amino acids don't also, even though we have the 200 to 500 exact amino acids inside pore, they don't touch together, they don't connect together. Why do they bond together? They don't bond, actually. So that's the second. Amino acids don't link together naturally. just stay there together. And then third one, every one of the perfectly arranged amino acid would have to be of the left-handed amino acid. How could this one possible in nature? How could they get rid of all D type and only remain on the L type? It's not possible at all. Not possible. And this is almost last part of the already finished. It's very simple. The probability of making one protein from the pool of amino acid. So we now, okay, standing the list experiment, okay, everything is fine. Everything amino acid is made. Now we have 20 different amino acids inside the chamber. Everything is abundant. Now they bond together. And then what's the probability to make one protein naturally? This one I'm going to explain about. Because we have 20 different amino acids, the first one has to be chosen by out of 20, right? So first amino acid, the probability of chosen, the first one is 1/20. Correct, right? For the second amino acid, also 1/20. That's probability. Times. How many times we have to do? How many chains? At least 200. So 1/20 times 1/20 times 1/10 times. At least you have to multiply 200 times. That's the probability you can make it the simplest protein. If it's a complex protein, at least 500 times. So that's the result. 1/20 to the 200 power. So I made some math work. So I split this one. This is 1/2 to the 200 times, 1/10 to 200 times. I forget about this one. Okay, let's give that away. Forget this. Let's talk about this one. 1/10 to the 200th. That's the chance, probability to make one protein naturally, even though everything is ready. Okay, what would be the probability you can get the jackpot? Do the lottery. What would the probability? Okay, anybody can guess it?
Was it not like a million?
1/billions? Yeah, it might be right. Billions, or maybe 10 billion. The billions means 1/10 to the how many power? 9 power. 10 billions means 1/10 to the 10 power. But still, we don't believe that probability. That's why I'm not buying jackpots. We don't expect those. 10 to the 10 to 200, how much is going to be? I'll show you something. The number of atoms in the universe is 10 to the 80 power. The number of atoms in entire universe is less than 10 to the 80 power. Then you know how great 10 to the 200 power. So 10 to the 80 power, meaning is, what's the probability? Is this probability? The universal equal to this universal dot game. The meaning of the probability of the 1/10 to the 80 means when you throw a dart from outside the universe, the probability of hitting a specific target atoms. That's this probability. You see the outside universe, you throw the dart, then that dart goes exactly, not the New York UBF, not to anybody, to the atom, one atom in the universe. That probability is 10 to the 8 power. But in order to make one protein, simple protein, how much power we need? 1 to the 10 to the 200, at least. Then we make one protein. Now, how many proteins do we have? So the conclusion is, it is not just impossible. Impossible. I cannot say just impossible. It's really impossible to produce even one protein in nature. That's period. So we cannot make one protein. Don't talk about organelles. Don't talk about cell. Anything else? It's not possible at all. In a simple cell, there are 600 of different protein. In a simple cell, one cell, amoeba like cell, 600 different protein. How about our bodies? We have 30,000 different protein in our bodies. how do these all things made by naturally? Do you believe this one? Wow, great faith. I cannot, scientifically, I cannot trust in this one. So life, no life can start naturally. That's concluding. Protein does all the jobs of the cell, and protein is function like our hair and muscle and skin cell enzyme. This all is made out of proteins. Okay, so and last of all, I'm going to show what things happening in this video. Is 7 minutes, a little bit long, but it shows you what kind of things happen in the cell, in a simple one cell. It's really like chemical factory. So just a little long, but just watch it, please. Yes. This is a keyword, my keyword for this presentation. Romans chapter 1:20. Since the creation of the world, God's invisible qualities, His eternal power and divine nature have been clearly seen, being understood. Are you understood today? Being understood from what has been made, so that men are without excuse. So we cannot excuse actually. Just think a little bit. It's obviously life cannot be formed naturally. Life came from God, designer, creators. So meaning is that's truth. Life comes from God. Means my life is not mine. It's God's actually. But we act like that we are the owner of my life. We live like I'm the owner of my life. We don't want to acknowledge God. Why? Because we don't like it. If you acknowledge that my life came from God, God is my Lord of my life, then I can do by myself everything what I want. That's why people suppress the truth. God can read one more Bible verse. Same thing, Romans chapter 1. It's 1:18. The wrath of God being revealed from heaven against all the godlessness and wickedness of men who suppress the truth by their wickedness. They suppress the truth. And after that, this is the Romans chapter 1:18. After 20, talk about the creation. God is creator. Means suppressing truth means people suppress truth that God is creator, His owner. God is our owner and creator. So why? Because man's wickedness. So wickedness, it doesn't mean that we made a crime, we commit crime. Wickedness means we reject God's lordship upon our life. That's the wickedness. That's very wicked before God. So we young people, think about it. Still you didn't acknowledge your lordship of God in your life. You are very wicked before God. That's what the Bible said. So I hope everybody just give a life to God, live but God's under God's lordship. That's the most blessed life. If you live like that, according to John chapter 8 verse 31, you know the truth, and truth will set you free. If you don't give our life to God, become a slave of sin. That's what the Bible said. But we serve the Lord, we are free. Free. That's the what Bible promised, and everybody also experience by walking with God every day. Thank you. Any questions? That's all.